An important visual metaphor for thinking about how natural selection operates is something that we refer to as the adaptive landscape. This was a concept developed by Sewell Wright, a population geneticist and biologist in the middle of the 20th century, but it's an important way of thinking about how phenotype, environment, and genotype are connected via natural selection. The basic idea is that any individual phenotype has a specific fitness associated with it given a specific environment. Now that fitness in this case refers to basically how likely an individual with that phenotype is to survive and reproduce into future generations, or basically how fit they are for their environment, how likely they are to pass on their genes. So there are areas of high fitness within this landscape, there are areas of low fitness within this landscape. Now, given a certain population starting point, we might have population scattered across right here, for example, natural selection is going to tend to drive populations towards areas of higher fitness. And any traits that develop, phenotypes that develop because they become more frequent, because of a process like this, are what we refer to as adaptations. So an adaptation is a trait that's become highly frequent in a population because natural selection has made it more frequent within a population. It's a trait which confers high fitness. In other words, it reflects that evolutionary fit that Darwin observed between organisms and their environment. Now, there are a few important concepts to illustrate out of this. The first is that evolution doesn't necessarily optimize an organism's phenotype. Rather, it optimizes within a local context. So if we imagine this initial starting point of this population as being someplace different, for example, say here, we would expect natural selection to drive it to the locally highest fitness peak, or perhaps maybe through other actions driving it up towards this way. But neither of these peaks are as fit as this initial one that we illustrated first. The reason being that evolution can only operate on the variation that's present within a population. Another important point to illustrate out of this illustration is that relationship between phenotype and genotype is important. Again, genotype develops into phenotype. If we have changes within that process, that can also alter how natural selection operates on a phenotype and at what level natural selection is operating on a phenotype. So this notion of development, this idea that phenotype is the developmental outcome of genotype, is a concept that we're going to refer to repeatedly throughout the semester. Finally, it's important to note that natural selection is not random. Natural selection acts in a specific direction. It takes a population from its starting point and moves it to areas of higher fitness, assuming those areas are available to it. This is different than the other forces of evolution that we've talked about. Mutation and genetic drift are both random in specific context of that word. Mutation is random in the sense that a mutation that's more likely to produce higher fitness is not necessarily more likely to emerge. Once that trait has emerged, that high fitness mutation might be more likely to persist, but mutation itself is random with respect to outcome. Things that are advantageous aren't more likely to come about. The same is true with genetic drift. Genetic drift is also random. Genetic drift is driven by the frequency of a trait within a given population, not necessarily by how likely or how advantageous that trait is within that given population. Another thing to note about this also is that as the environment changes, we would expect the actions of evolution to change as well. If this environment changes from time 1 to time 2, for example, if we imagine this fitness peak shifting, we would expect evolutionary change in how natural selection is acting to shift according to that environmental change. So the action of natural selection is specific to a given time and place. As the properties of that time and place change, as the environment changes, as the phenotype of individuals within a given population change, or as the genotype of a population changes, we would expect natural selection to change in how it acts. One additional point is that natural selection is not synonymous with evolution. Natural selection might be the most memorable and notable form of evolutionary change, but it's just one force of evolutionary change. Not everything is an adaptation. Not every characteristic we look at was there because it was selected for. Many things that develop in our phenotype develop because of other kinds of developmental and environmental constraints. They come about because of other evolutionary processes, things like gene flow, things like genetic drift, things like mutation, and not because of the action of natural selection. So while natural selection was foremost in Darwin's mind when he developed the ideas of evolution, natural selection is not the only force of evolutionary change, and natural selection is not synonymous with evolution. The exercises that follow this section will help reinforce these concepts. Mutation, which increases the amount of genetic variation in populations. Genetic drift, which leads to the loss of variation in populations. Gene flow, which serves to structure how variation is patterned across populations. And natural selection, which does pretty much whatever it wants and shaping how variations is situated within populations to help you better understand these concepts and how they relate to human evolutionary history.